Hi, let's construct LR automata and LR parsing table with example 3. I already discussed two examples how to construct LR automata and LR parsing table. First step, we need to write the augmented grammar. Augmented production will be S dash derive S. Then we'll write the grammar that S derive AA, S derive BB, A derive D, B derive D. Now augmented grammar is done. Next we need to construct the LR automata with the LR0 items. Now there will be initial state with the production S dash derive dot S. There is a dot before S, so you need to write S production, that S derive dot AA, then S derive dot BB. There is a dot before A, so you need to write A production, that A derive dot D. There is a dot before B, so you need to write B production, that B derive dot D. There is dot symbol before S, before A, before B, before terminal D. So there will be 4 transition with S, A, B, D. Let's first do with S. And we'll assign one state name to this state, that will be I0. Now from I0 state by S, it will go to another state where production will be S dash derive S dot. This dot symbol was before S, now dot symbol is after S. And we'll assign one state name, that will be I1. Next from I0 by A, it will go to another state where production will be S derive A dot A. This dot was before variable A, now dot is after variable A. And we'll assign one state name, that will be I2. Then from I0 by B, it will go to another state where production will be S derive B dot B. Dot was before B, now dot is after B. And state name will be I3. Next we will do the D transition. From I0 by D, it will go to another state where production will be A derive D dot, B derive D dot. And we will assign one state name, that will be I4. If you are just checking whether the grammar is LR0 or not, you can stop here, as this is a reduce conflict. In one state there are two reduction, so this is a reduce conflict. You can stop that. Even by just seeing the grammar, you can say that there will be reduce conflict due to this D. From one state by D, it will go to another state where these two reduction will be there. So this is a reduce conflict and it is not LR grammar. If there will be SR conflict or reduce conflict, then the grammar is not LR. Let me finish the construction of LR automation and table and check whether this is LR grammar or not. Now for I0 we did all the transition. Let's check for I1. I1 is accepting state, so there will be no transition. Next check for I2. In I2 there is a dot before terminal A. So from I2 by A, it will go to another state where production will be S derive A dot. This dot was before terminal A, now dot is after terminal A. And assign one state name, that is I5. Now I2 is done. Next check for I3. From state I3 by B terminal, it will go to another state where production will be S derive BB dot. And assign one state name, that is I6. Now for I3 all transition is done. Next check for I4. I4 is a reduction, so there will be no transition. I5 is a reduction, there will be no transition. I6 it is a reduction, there will be no transition. Let's assign some reduction number, like this is R1, this is R2, this is R3 and this is R4. And this augmented production, that will be asset. Then I5, that is R1, I6, that is R2, I4 that contain R3 plus R4. Now LR automata is done. Let's create the parse table. There will be two parts. One will be action, another will be go to. Action will contain all the terminal. Terminal are A, B, D with dollar, and go to will contain all the variable. At LHS we will write the state number. You can write I0, I1, I2 or simply 0, 1, 2. State name is not matter. In previous two example I have written I0, I1. Here I have just written 0, 1, 2. All are okay. So we'll do one by one row. Let's do for 0 row. From state I0, there is just one transition with terminal D, that is going to I4. So in D column, write down S4. Then from I0 state by S, it is going to I1. So we'll write simply 1 in S column. In case of go to, we'll write simply the state number. In case of action, we'll write shift and state number. Then from state I0 by A, it is going to I2 state. So just write down 2 in A column. Then from I0 by B, it is going to I3 state. Just write down 3 in B column. Next we will do for I1 state. I1, that is a accepting state, we'll simply write accept in dollar column. Next we will do for I2. From I2 there is just one transition by A, it is going to I5. So just write down S5 in A column. Next we will do for I3. From I3 by terminal B, it is going to I6. So in B column we will write S6. Next we will do for I4 state. In I4 state there are two reduction present. One is R3, another is R4. So in all part of action we will write R3 and R4. There are multiple entries, so the grammar is not LR0. This is a reduce conflict. Next we will do for I5. This is a reduction and reduction number is 1. So we'll simply write R1 in all column of action part. Next we will do for I6. I6 is a reduction and that is reduction number 2. We'll write R2 in all column of action part. Now parsing table is done. This is not a LR0 grammar as there are multiple entry, or you can say there is reduce conflict is present. If there is shift reduce conflict or reduce conflict, then grammar is not LR. Just by seeing the grammar, you can say that there will be a reduce conflict. Just say from this by D, it is going to one state, and in one state there will be these two production. A derived D dot and B derived D dot. So there will be reduce conflict. Or you can simply construct partial LR automation, means you can just construct up to this and you can stop here and you can declare that the grammar is not LR. If this lecture is helpful for you, please like and subscribe. Thank you.